The shuttle's aero surfaces now are being used for control of pitch. The steering jet's turned off for pitch now, and its wing ailerons being used for control. The rudder will not become active for use until after the shuttle's gone subsonic as it crosses the California coast. Discovery now reversing its banking back to the right. The second of 4 banks it will perform as it approaches California to slow down, dissipate speed. A right bank with wings angled about 70 degrees. Range to touchdown now 1,220 miles. Altitude 39 miles, or about 210,000 feet. Discovery speed 12,620 miles per hour. This graphic from Mission Control shows Discovery's projected path as it closes in on Edwards Air Force Base. Its course taking it directly above central Los Angeles and above Palmdale, California, en route to Edwards. Palmdale, the site of the factory where Discovery was built. To touchdown at Edwards Air Force Base now as Discovery continues across the Pacific at an altitude of 35 miles. Discovery speed 10,550 miles per hour. Range to touchdown about 800 miles. Discovery speed 8,100 miles per hour, altitude 32 miles or 172,000 feet, 535 miles to touchdown at Edwards Air Force Base, runway 22. As Discovery approaches Edwards, it will make a right overhead 204-degree turn to align with the runway. Discovery now reversing its bank, performing the third of 4 banks it performs as it approaches California to slow down, banking back to the left now. The wings angled about 70 degrees to horizontal.
Discovery, Houston, energy, ground track, and nav are go. Balloon data and FTA runs agree with the touchdown 2,200 feet down the runway at 195 knots. New altimeter is 30.09. Discovery Houston, take TAC hands, and did you get our last call?
Yeah, we sure did. On 2,200 feet, you said, and we'll take the TAC hands.
Those calls first indicating that Discovery is right on target with its altitude and speed and onboard navigation for Edwards Air Force Base, and also that the crew can now take tactical air navigation data for use as to update the onboard navigation. That is bearing information for the shuttle that's supplied by a radio beacon on the ground from Edwards Air Force Base vicinity. Miles to touchdown at Edwards Air Force Base now. Discovery's altitude 145,000 feet, speed 4,930 miles per hour. 10 minutes to touchdown on runway 22. Nine minutes to touchdown for Discovery now at Edwards Air Force Base. Discovery speed Mach 5.2 times the speed of sound, or about 3,500 miles per hour. Altitude 120,000 feet, or about 22 miles. Range to touchdown 161 miles. Discovery is approaching the coast of California. Its course will take it almost directly above central Los Angeles. As it goes subsonic and approaches the coast, sonic boom should be clearly audible in the Los Angeles area. Discovery now performing its fourth bank as it approaches the California coast to dissipate speed, banking now back to the right with wings angled about 40 degrees from horizontal. This is a close-up view now of Discovery's final approach toward Edwards. As it approaches Edwards, it will perform a right overhead 204-degree turn to align with runway 22, that around an imaginary cylinder called the heading alignment cylinder that's created by a microwave landing system for the shuttle installed at Edwards Air Force Base.
Discovery Houston, take air data.
Taking air data.
That call to the crew that they can use information supplied by air data probes that are deployed from the nose of the spacecraft for use in navigation. They supply supplemental information on airspeed and altitude using barometric pressure and wind speed. Discovery speed now 2,000 miles per hour, or about 3 times the speed of sound. Altitude 89,000 feet. 78 miles to Edwards Air Force Base. 6.5 minutes to touchdown. Have a live television view of Discovery now. In the center of this view, Discovery Mach 2.5, 2.5 times the speed of sound. 69 miles to touchdown at Edwards Air Force Base. Speed 1,470 miles per hour. Discovery's wings leveling now as it approaches the heading alignment cylinder.
Discovery Houston, on energy approaching the hack. No change to winds or weather. Your go for nominal, shoot deploy.
Okay, down, copy on, and nominal shoot deploy.
That call that Discovery's right on target as it approaches the heading alignment cylinder. Again, that cylinder, it will perform a right overhead 204-degree turn around to align with runway 22. Discovery's altitude 65,000 feet. Speed 860 miles per hour. Discovery about to go subsonic and range to touchdown about 38 miles. Discovery speed Mach 1 times the speed of sound now. Altitude 50,000 feet. Four minutes to touchdown. Discovery with wings level approaching the heading alignment cylinder. Again, it will perform a 204-degree right turn to align with the runway. That's an imaginary cylinder created by the microwave scan beam landing system. This now a view through the heads-up display on board Discovery. This point of view of the pilot of Discovery from a heads-up display in front of pilot Pam Milroy. its right turn, a 204-degree turn to align with runway 22. Altitude 32,000 feet. Discovery speed 500 miles per hour. $16 miles to touchdown.
Discovery on at the 180.
That call that Discovery's right on target with 180 degrees to go in this turn to align with the runway. Wings angled about 50 degrees from horizontal as it continues on that right bank. Altitude 23,000 feet. Speed 500 miles per hour.
Discovery on at the 90.
Roger, on.
That call that Discovery remains on target, 90 degrees left to go to align with runway 22. 1 minute, 45 seconds to touchdown.
Runway inside, Houston.
Copy, runway in sight.
Discovery's wings leveling, altitude 10,000 feet. Altitude 5,000 feet. Feet. Landing gear down and locked on board. Main gear touchdown. Nose gear touchdown. Discovery home after completing one of the most complex missions to date and setting the stage for the first permanent occupation of the International Space Station beginning next week. Discovery rolling out on runway 22 at Edwards Air Force Base. 12 days, 21 hours, 43 minutes in orbit.
Wheel stop, Houston.
Copy, wheel stop, Brian. Your great landing today made everybody happy at Edwards Air Force Base. Welcome back to Earth after a super successful mission.
Great to be back, boss. You can follow.
Congratulations once again. We'd like to take FES Tri-Alpha to off, Brian.
Fire is off.
Discovery Houston, we'll meet you on page 5-3 for the post-landing checklist.
On our way. sounds like men or you're on clear?
Discovery home in California after more than 12 days, 21 hours and 43 minutes in orbit, actually landing, touching down at 12 days, 21 hours, 42 minutes and 41 seconds elapsed time for the mission at main gear touchdown. That came actually at 3:59:41 p.m. Central Daylight Time. Nose gear touchdown followed 13 seconds later at 12 days, 21 hours, 42 minutes and 54 seconds mission elapsed time, or 3:59 and 54 seconds p.m. Central Daylight Time. And wheel stop for Discovery came at 12 days, 21 hours, 43 minutes and 47 seconds mission elapsed time, or 47 seconds past 4 p.m. Central Daylight Time.
Discovery Houston, Brian, you have a go for rad reconfig on page 5-8.
Roger, rad reconfig 5-8. And Houston Discovery, just confirm you'd like ammonia be fried GPC when we get there.
Brian, that is affirmative.
Houston, ET umbilical doors are coming open.
Pam, we're watching the doors, and Brian, we're ready for ammonia activation.
Okay, here we go. side hatch, drag chute, and landing gear are safe.
Houston copies. Thanks, Brian.
Houston, are you going to be looking for a hydraulic load test today?
Brian, that is affirmative. Hydraulic load test is required.
Okay, we'll put in work. Okay, Houston, we're going to take the body flap full down if you'd like it.
Brian, we are go for setting the body flap. Discovery Houston, after the body flap's down to 100%, you're go for the DPS transition to Ops 9.
Okay, we show it full down, and we'll move it to Ops 9.
watching for Ops 9.
Houston, we're ready for the SSME repo.
Sam, you do have a go for SSME repo.
That's it. Houston, it looks like we got a good SSME repo. We're going to APU hide shutdown.
Sam, you have a go for APU hide shutdown, and Brian, when you get there on page 5-10, you'll have a go for extended power up.
Okay, copy, go for extended power up.
This is Mission Control Houston, and back with a live shot of Discovery on runway 22 with the shuttle landing convoy in position, setting up cooling to the spacecraft and testing the area around the spacecraft to ensure that it's safe with no toxic fumes from any shuttle systems.
Discovery Houston, Brian, you do have a go to take your suits off.
Okay, down, thanks a lot.
Coming up shortly on NASA television, originating from the Kennedy Space Center in Florida, will be a post-landing press conference, that with Space Shuttle Program Manager Ron Dittemore, expected to be coming up shortly, originating from the Kennedy Space Center, a press conference with Space Shuttle Program Manager Ron Dittemore.
Houston, APU hydraulic shutdown is complete.
Copy, Pam, see you going into now post-landing MPS reconfig.
The STS 92 post-landing press conference.
Good afternoon, and thank you for joining us today for the post-landing press conference originating from Kennedy Space Center for the mission of STS-92. We have with us today NASA Shuttle Program Manager Ron Dittemore. He will give us a few comments about this mission, and then we'll take some questions from the media. Ron?
Okay, thank you. You know, a wise friend of mine told me some time ago that the road to success is always under construction. And it sure seems like that sometimes. You have a pothole here or a bump there that you have to overcome. As we prepared for STS-92, we had our fair share of bumps and potholes. We had some weather that we had to overcome. We had a couple of hardware problems that we successfully managed to convince ourselves were fine to launch. But once we got rolling, this flight crew and this team did a tremendous job. They installed the Z1 truss. They added a new docking port. They performed 4 fabulous spacewalks. And they culminated today's activities with a picture-perfect landing at the Edwards Air Force Base. And I couldn't be more happier and pleased with the results of this mission. And I think it puts us in a great position to start the permanent human presence of International Space Station with the launch of the increment crew a little less than a week away. We're preparing now for our next flight on November 30th, and we're looking forward to that event where we'll send a crew up to meet that first crew that will already be there. We'll have a welcoming committee the next time we go. So we're looking forward to that. And again, I'd say we had a fabulous mission, a great start in this assembly process.
Okay, at this time we'll take questions from the media. We'll start up front with Marcia Dunn. State your name and affiliation, if you would, please.
Marcia Dunn, Associated Press. Given the 6 days delay in getting the shuttle up and the couple of days in the ferry flight, how does that February flight look by Discovery? Can you talk about the turnaround that you face?
Well, right now we're looking at a 65-day OPF flow, but we have a fair amount of margin. In this time frame, we've got 13 holidays, and we've got about 6 premium days. That's weekends that are not committed. We always carry a 6 to 7 day Dryden reserve, which in this case we're going to use up. So on top of that, 13 holidays, 7 premium days, I think gets us in a good position to have a good run at February 15th.
Okay, so right now there's no reason why you can't make it.
Right now I see no reason why we can't still aim for the middle of February.
Thank you.
Okay, Phil?
Phil Chen, Earth News. Let me follow up on that. 65 is still really tight. It's one of your fastest post-Challenger turnarounds. Can you do that now with your workforce, given also the fact that you've got 2 other vehicles who are going to need processing at the same time?
Well, we have some good data points. You know, we just turned around 104 pretty quickly from STS 101 to STS 106 this summer. We were processing 2 other vehicles at the same time. We turned it around in 69 days. So I think it's in the ballpark, and given what I just told Marcia, that we have some premium days and some margin, I think that's certainly feasible.
And over the last 3 days, do you have any number on how many times the crew had to fluid load while they prepared for all of these landing attempts?
I'm sure probably more than they wish to, but I really don't know how many times they did. I suspect just a couple of times.
And since Tommy is not here, I suppose we get to ask you, in the various management team meetings, have you heard of any concerns, any possible showstoppers to next week's launch from Baikonur?
Well, I can tell you that all the folks are packing their bags. They're going to leave for Russia at the end of the week.
Okay, we'll go over to Bill Harwood, then we'll come back over here to this side.
Bill Harwood, CBS. Tommy, again, realizing you're not a station guy and you're the shuttle guy, once the crew gets on, I was just wondering if you could talk for a moment about philosophically. It seems like a change in emphasis with the shuttle program. Every flight's important, but once you've got a crew up there, it just seems like the program's really taken on maybe a new life. I was just wondering how you view the significance of that launch, and is there anything in the back of your mind once that crew's up there that maybe wasn't there before?
Well, it starts a new activity for us. Once you start permanently manning the station, then you have certain dates that you would desire a crew rotation. Logistics, supplies, food, consumables becomes more important to you because that's keeping life, limb, home, all just the way you want it. Marcia was talking about the flight in February. That would be our first crew rotation flight. certainly we'd like to keep it in around the same time frame we're planning, because crew rotation, resupply is going to be an important factor for us. So it opens up a whole new avenue for us and accelerates our thinking on the planning, what we're doing for our margin on our certain flights, making sure we keep enough margin specifically for crew rotation flights. Those are going to become more important to us. As we encounter challenges in our assembly phases, and certainly we'll have some, we need to plan and strategically think about how we're going to manage these crew rotation flights on the shuttle, and when we're going to have the logistics resupply, and interspersed between the shuttle you got progress resupply. So between Tommy and I, we'll be working closely and carefully to manage that overall activity.
And just a related question on looking at crew rotation flights. I mean, as this flight showed, on any given mission, you can really get bit by the weather and things like that. And you've had a good string of good luck for a couple of years where that didn't happen. A mid-60s kind of flow is a tight flow. I mean, do you think you'd give any consideration to perhaps trying to build in a little extra margin where when these things happen, it won't bite you on the other end?
Well, I think in this situation that we just talked about, there's plenty of margin to meet the 65 days with the holidays and some premium days, a good week of premium days. And we certainly do consider that as we look into the future with our manifest. So I think we've already done that, and we'll continue to.
And one final quick one for me. Are you guys going to fly Endeavor, and I should already know this, but are you guys going to fly Endeavor with the current KU system, or did you guys decide to swap that out? I just didn't know.
No, we didn't. We decided that we have no knowledge of what the failure is on 103 and won't have for some time. And it could be any number of different items in the KU band system. We believe we have a good system on 105, and we decided to fly with it.
Okay, Todd?
Todd Halverson of Space.com. On the next mission with the P6 arrays, I'm wondering if you're working any problems right now whatsoever that would push back a planned November 30th launch.
Well, I ask Tommy that question almost every day, and he tells me that he's on schedule to deliver his P6 by the middle of November, and that keeps us on a November 30th launch for the shuttle.
And in terms of the complexity of that mission, it seems to me that unfurling those huge solar arrays is kind of a complicated endeavor. Could you give us an idea of how to put that in perspective, just how difficult that'll be?
Well, you probably ought to ask, it'd be more, let me just say it better be asked of a station person or an EVA. I'm not as familiar with the exact tasks that they'll have to do to put that solar array out there, so I'll defer that.
Just one other one from me. I was curious as to whether there is any drop-dead date in December for getting that mission off the ground because of the holidays, or if you guys would be willing to fly it over the holidays if need be.
No, I believe there is a beta cutout towards the third week of December, and I don't have the date right off the top of my head, but that would prevent us from launching late, like past the 20th or so. But we could certainly launch up to the 15th or 16th, and if it's a 10-day mission, then it's very similar to what we did last year with the Hubble Space Telescope. That certainly could come back again. We could be in the same situation. But right now I don't see anything that puts us that far into December, but we have the possibility to launch up to about the third week of December before we hit that cutout.
Just one other quick one from me. Is the lab still holding firm for mid-January?
I'd say it's as firm as everything else we have in the schedule.
Come down front over here.
Kiyoshi Ando of Japanese newspaper Nikkei. Before the launch, you were mentioning this mission as one of the most challenging tasks. There will be a lot of difficult things. After this is being finished, if you are to give them a grade, what do you think they've earned?
A+. I mean, remember what I told you before, that this was one of our most complex missions. We were adding some things to the space station we hadn't done before. 4 spacewalks. In fact, I don't think we have any other assembly flight that's got 4 spacewalks planned. Most of them have 3 around that neighborhood. And I mentioned to you, not only were the tasks increasingly complex, we were raising the bar in the number of activities that we were doing. And these fellows did a great job. Everybody in the crew did a super job. And not only the flight crew, but the team on the ground that coordinates the planning from day to day and adjusts to the things we perhaps don't get done and then replans it. Coordinates our activities with the Russian space program and the control center in Moscow. A+, everybody all the way around. Super job.
And do you think this will give you a chance to raise the bar even higher?
Well, we like to think that we're doing a pretty good job as we raise the bar. Certainly, this one's going to be hard to beat because for what I just talked to you about. But every mission is going to be a challenge. Each will carry its own peculiar set of challenges. As Todd mentioned, we got the solar rays coming up on STS 97. There'll be the lab on STS 98. Each mission has its peculiar set of challenges, and we'll take one at a time.
Just quickly, one more. Because of this delay, both launch and coming back, what is the cost of the whole thing combined? Because of the delay that it will cost additionally.
You're saying, is there a delta cost? There's not a delta cost for the fact that we delayed landing a couple of days or we delayed launch for a couple of days. I'm not hiring any more people. I'm not letting any more people go. So the cost is no change.
Transportation, I mean, just the carrying of
the transportation would be the price of the jet fuel, and again, that's very small compared to the infrastructure and the workforce that we maintain.
Okay, we'll take another question from Steve Seisloff before we go out to Dryden Flight Research Center. Stephen?
Yeah, Ron, I have just a quick question. Steve Seisloff, Florida Today. I was wondering if there was any consideration today for holding off one more day to try tomorrow at KSC, if that was ever.
No consideration at all. In fact, if the weather was a little better yesterday at Edwards, we would have landed at Edwards yesterday. It's unfortunate that in October it's kind of windy here in Florida, but it was for the last several days. But Edwards is there as our backup landing site, and we've had a good string of landings at Kennedy. In fact, the last time we went to Edwards, I'm sure you know, was March of 1996. We prefer to land at Kennedy. It gets us a leg up on our processing. But we put on our plans the possibility that we could land at Edwards. We build in the margin, so it should not be a significant impact to us.
Okay, and at this time we'll go to Dryden Flight Research Center in California and take questions from there. Go right ahead, Dryden. Okay, we're standing by. It sounds like they're trying to gather their folks towards the microphone. Are there any other questions here at Kennedy while we're standing by? Any follow-ups here in the room? Bill?
I don't see that as a problem. Let's get into the root cause quickly.
What were the things you zeroed in on?
Well, one was the keel camera. Another one was the space vision system box. Those two areas for certain, and we can those out fairly easily.
Any other questions here at Kennedy? Down front to Phil.
We can certainly perform the rendezvous without the radar system. Brian Duffy did a super job at piloting the shuttle with a minimum amount of extra prop usage. The major inconvenience is that you don't have as much data up and down. You don't get TV like you'd like to see it, and it kind of hampers your communication of the way we send up plans. But we have alternate options. We send it up S-band. It's a little slower rate, doesn't have as great a capability, but certainly we did that for many years, so we're certainly able to do that.
But if for some reason you do decide to replace the KU, any idea how many days hit that would be into the Endeavour launch date?
I'd say that's just speculation, Phil, and there are no plans to replace the KU band.
Okay, and at this time I believe we're ready for a question at Dryden Flight Research Center. Go ahead, Dryden. Sounds like we're having audio difficulties. Do we have a question at Dryden?
Yes, can you hear me?
Okay, I guess what we'll do this time is we'll try to get a hold of that question over the phone and get that on. And with no other questions here at Kennedy Space Center, we're going to go ahead and conclude this conference. Thank you for joining us.
This is Mission Control Houston. We're back with a live picture of Discovery on runway 22 at Edwards Air Force Base, California.
Houston Discovery contract.
Discovery Houston, you're loud and clear.
Okay, Dom, loud and clear as well. We're just kind of getting towards the end of the checklist here. Do you guys see that we missed anything?
Brian, we see everything done complete and done well.
Well, thanks, boy. It's great to get to the end, and I want to thank everybody there. I know you guys worked really hard to get us down, and you guys made all the right calls. The hard calls are the hard ones to make, and you guys made them, and we appreciate you doing that. And thanks for bringing us home. We were thinking this morning that maybe the wake-up music might be like "It Don't Come Easy," but this was great. It was worth waiting for, and we couldn't have done it with all of you. So thanks very much.
Well, Brian, it was our pleasure, and it looked like a great, perfect landing. I'm looking forward to seeing you guys back at Ellington.
Okay, and we're probably going to be heading over here to the aft shortly and leaving the vehicle, so we'll see you guys back home. And once again, thank you.
And Brian, one other thing, we'd just like to get a comm check with the ASP before we disconnect from the rest of the crew.
Yeah, I'll make sure we do that. We haven't got anybody off the flight deck yet, but I'll be the last one off, so when I give it, I'll make sure he checks before I leave.
Okay, Brian, who's the ASP today? Is that John?
Yeah, Dom, ASP is up.
Good afternoon, John.
And Houston, I heard you loud and clear. Houston, the cruise egress any vehicle this time.
Houston copies. Discovery Houston, just a heads up, in a minute or two we're going to be calling you for ammonia reconfig on page 5-22, and that's going to be Alpha Pi GPC.
Okay, Tom, still with you.
Discovery Houston, Brian, if you're still there, we're ready for ammonia DEAC on page 5-23.
Okay, Tom, yeah, ammonia DEAC 5-23. Discovery, ready to check on out of here, Dom. I'd like to congratulate Leroy on doing such a great job on his first entry, and it couldn't have gone any better.
Hey, Brian, you can hear the applause. There's a lot of people that agree with you, and he says thank you.
Okay, and I'm going to sign off. I'll see you guys back home.
We'll see you then. Discovery Houston, no action on the EVAP out T.
And Discovery copies. Houston asked all crew members are out of the orbiter.
Houston copies, everybody's out.
This is Mission Control Houston as we continue to see television of Discovery on runway 22 at Edwards Air Force Base. After traveling 5.3 million miles during its 12-day, 21-hour, 42-minute, and 54-second long flight on STS-92, this concludes Public Affairs commentary for Shuttle Mission STS-92.
Okay, are you able to... You guys let us know when you're ready. Let me know when you're ready. The mic's on and everything. Well, we're sure glad to be back here. What a great day to end STS 92. We had a terrific mission, and it was. I think it'll go down as being very successful. We certainly had a good time while we were up there. While we were there, we know that we helped the future of the International Space Station, and in so doing, we helped the future of the space program. I have to tell you that we would not have been successful as a crew without all of the help that we got on the ground before the flight in preparation, or from our training team and from the mission control team that trained with us and did all the analysis that we needed so that we'd be successful while we're in flight. Special thanks goes to all of those folks that gave so much out of their own lives to dedicate it to this mission. A lot of people have a lot of personal sacrifice in order to do this. The mission would not have been successful, however, without the great group of folks I have behind me, my crew, and I'm going to give each one of them a chance to say hello. We want to thank everybody here at Edwards, which us Air Force folks consider to be the mecca of flying, particularly test flying. So to be able to come back here and fly in a space shuttle and land it here at Edwards Air Force Base is a very special thing for me. I think you'll hear the same thing from Pam Melroy. Just to introduce the crew, my pilot was Lieutenant Colonel Pam Melroy, the Mission Specialist number 1, Dr. Leroy Chow, Mission Specialist number 2, Colonel Bill MacArthur, Mission Specialist number 3, Dr. Jeff Weissoff, Mission Specialist number 4. You'll hear from Commander Michael Lopez Alegria. And lastly, you'll hear from Mr. Koichi Wakata from NASA, who's the Japanese astronaut. So first, I'd like to give Pam a chance to say a few words here about our mission and landing here at Edwards. So, Pam.
This is just an awesome moment. We just wrapped up the 2 most incredible weeks of my life. They were unbelievable, indescribable. But what was wonderful about it was that we went out there, we went out to do something really hard. We had this enormous team of people who were all really working hard, and it was just amazing how everything came together. And we did these really hard things, and it was so much fun at the same time. And I think for me, what really capped it off was actually coming here to Edwards, where I was based for 4 years, so it feels like home to me. And when we flew in and rolled out on final, that lake bed looked so familiar, the runway, the whole base. It just makes me so happy to be here. And I want to thank everybody who supported us here and in Houston and at KSC for an incredible experience.
I can't tell you how wonderful it feels to be back on the ground after a very successful mission. I couldn't be more happy about the way things have gone, and I'd just like to add my thanks and echo thanks to everyone on the ground who made this possible, all the training team, the folks in the Mission Control Center, helping us work all the problems that Mr. Murphy put in our way. And I'm just very, very happy that we achieved all of our objectives, and especially the assembly objectives, so that the next flight can go up and 4A can go up and do their mission in just about 6 weeks or so. Anyway, with that, I'd like to turn it over to Mission Specialist Bill MacArthur, MS2.
Wow. I don't know what else I can say, but this was an experience that just is incredible. But it wasn't easy. We had to work really hard. We had to overcome a few things, a few problems in the flight, communication difficulties, electrical problems. And the reason we did that is because the 7 of us weren't flying up there alone. We were up there representing the entire human spaceflight community, the people who build our hardware, our trainers, and those are the people who get credit for this success. It was a tremendous experience. We think we accomplished some tremendous things. but we did it only because of the tools we were given, both hardware and in training. And so to all those people out there, I would like to say thank you. But also I would like to thank our families, our spouses, our loved ones, our significant others, because they are the people who worried here on the ground, who had to take care of things back home while we were in space. And to you ladies and gentlemen, I say thank you. And now I'd like to turn it over to Mission Specialist 3, Jeff Weissoff, the organizational genius who really allowed us to keep things together in space.
I'd like to start off by echoing Bill's thoughts and thank the families. The support of the families really helped us through this flight. We trained a long time for this flight. It was a very successful flight, and we really owe a great deal to their support in getting ready, because it takes us away from home for a long period of time when we're training. We really feel that the team that supported us, the whole NASA team, did such a superb job. We really accomplished all of our goals, and we're really looking forward to the future of ISS. We feel that the welcome mat has now been rolled out for the Expedition 1 crew. They're going to be next, and we're ready to turn over our EVA hard hats to the 4A crew. And we're just really feeling great about how the mission turned out. I'd like to now turn it over to Mission Specialist number 4, Commander Michael Lopez Alegria, who led all of our very successful work in the ingress of the station.
Hi. What you see behind us here is a sort of, beside the shuttle, is an unusual conglomeration of weird-looking machines and ungainly vehicles, but more importantly, the people who are operating them. And what that represents is another part of the huge variety of people that are involved in a project like this, from processing the vehicle to its launch, to its on-orbit operations, and to its landing out here at Dryden. This spaceflight is a team sport, whether it's from us talking while we're EVA to our RMS operators, to the pilot and commander communicating to each other during a rendezvous, or the landing, or from us talking to the ground to the guys checking out the weather like the STA pilots. And when a team works well, the mission goes well, and I think despite some obstacles that we overcame, it was a good mission, and we achieved another milestone, and we're looking ahead to press on to 4A. The first increment crew will be launched here shortly, and the rest of the assembly sequence to the International Space Station. I'd like to hand it over to Kuchi Wakata from the Japanese Space Agency NASDA, also the primary arm operator on our flight, and just simply the man.
Good afternoon. I'm very happy that we have accomplished all the tasks that we needed to do on this flight. It was a very wonderful flight, and the reason why we were successful was only because we had wonderful teamwork of the space station and space shuttle program folks, and the folks at the Mission Control Center in Houston, as well as in the Mission Control Center in Moscow, and the people in here on board. I'm very happy to be part of this wonderful team. ただいま、地球に帰ってまいりました。本当に素晴らしいフライトでした。宇宙ステーションの組み立てのための目的をすべて、達成することができたことをとても嬉しく思っています。これは、我々宇宙飛行士、そして、地上、ミッションコントロールセンターヒューストン、それからモスクワの、地上管制局の皆さん、そういった方々の素晴らしいチームワークがあったからこそできたことだと思います。本当にこのフライトを支えてくださった方々に心から感謝したいと思います。本当にありがとうございました。Thank you.
Well, to sum it up, I'm in total awe of what the people standing behind me have done over the last 13 days, and what that vehicle that you see behind me has done, and what the team that supported us and got us into space and back has done. So with that, we'll conclude this this little conference here and call it a day. Thanks very much.